Students, welcome to my YouTube channel. In this video lecture, we are going to solve further questions from Keith Williams' Weight and Balance book. The name of the chapter is Basics. So it's the very first chapter in this Keith Williams' Weight and Balance book, and it includes all the basic questions of weight and balance, like payload, the definitions, the formulae, etc. So let's look at new question today. Question number 91. The center of gravity datum of aircraft is what? It is always on the longitudinal axis at some point between the nose and tail, is always on the longitudinal axis but not necessarily between the nose and tail, is always at the nose, is always at some point between the leading edge and trailing edge of the mean aerodynamic chord. Now, in this picture, this black color line, vertical line, is your center of gravity datum. Okay, center of gravity datum. Now what is the center of gravity datum? Center of gravity datum is a place or is a point where all center of gravity calculations are made. Okay, so a place or a point from all center of gravity calculations are made. This is the first point, the definition. Next, second point is that this center of gravity datum can be placed or can be available at anywhere on the longitudinal axis of aircraft. What is the longitudinal axis? It is an imaginary line passing through the nose and the tail of aircraft. Okay, so imaginary line passing through the nose and the tail of aircraft. This is your longitudinal axis. Okay, so this datum can be anywhere on the longitudinal axis. Second point, it can be in your aircraft or it can be outside your aircraft, meaning it can be situated within the limits of your aircraft between the nose and the tail. Okay, like here. Or it can be altogether outside aircraft somewhere in front of the nose. Okay, so this datum can be outside your aircraft or somewhere behind aircraft like this. So the datum can be anywhere inside your aircraft, outside your aircraft, but it will be on the longitudinal axis between the nose and the tail. So, so the correct answer here is the CG datum is always on the longitudinal axis. Yes. At some point between the nose and tail, this part of the statement is wrong. Bravo is always on the longitudinal axis. Yes, but not necessarily between the nose and tail. Yes. The statement Bravo is the right answer. Option Bravo is the correct answer. Next. Variable loads include what? Passengers, crew. Okay, so passengers, crew, baggage, removable equipment, consumable fluids, removable equipment, crew and the baggage, passengers, crew, baggage and usable fuel, crew, their baggage and unusable fuel. So you have to remember this flow chart. Now we always start with the basic empty mass. We start from the basic empty mass, which is the mass of your aircraft plus standard items like unusable fuel, other unusable fluids, okay, emergency equipment, fire extinguishers, like that. So basic empty mass is the mass of your aircraft and standard equipment. When you add when you add variable loads to this basic empty mass, you get dry operating mass. You get DOM or dry operating mass. Now, what is variable load or what are variable loads? Variable loads is a common term for many items like such as crew, the weight of crew, okay? So the pilots, the cabin crew, crew baggage, right? Removable equipment and food, water. So this food, water, lavatory materials, all are a part of are parts of removable equipments. Okay, so these are variable loads. So basic empty mass plus variable loads gives you dry operating mass. Now we'll focus on the left side. Dry operating mass plus takeoff fuel, also called fuel on board. So what is takeoff fuel or fuel on board? It's the fuel available in your fuel tanks when you are positioned ready for takeoff on the runway. Okay, so this takeoff fuel or fuel on board will be exclusive of taxi fuel or run-up and taxi fuel, starting engines fuel. So dry operating mass plus takeoff fuel gives you operating mass. Okay, then look at the right side. Dry operating mass plus traffic load gives you zero fuel mass. Now, what is traffic load? Traffic load is nothing but payload, that is the load of your passengers and their baggage, plus any plus cargo. Okay, cargo and non-revenue load. This is called traffic load. So, when you add traffic load to dry operating mass, you get zero fuel mass. The name itself suggests the significance of this term. Zero fuel mass means there is no fuel. Okay, okay, so at this point you are not adding fuel on this side of the chart, you are adding fuel here. So when you just add fuel and not traffic load, you get operating mass. When you add payload or traffic load but not takeoff fuel, you get zero fuel mass. Okay, so there are two different ways. Next important point is operating mass. Now we have fuel. Now it's time to board passengers, okay, and cargo. So dry operating mass plus fuel on board is operating mass plus payload or traffic load. This was the missing factor. So now we are going to add that. And when you add that to operating mass, you get takeoff mass. Okay, takeoff mass is the weight of your aircraft at the beginning of takeoff run. So now, following this route, also you can get your takeoff mass. So, dry operating mass plus traffic load gives you zero fuel mass. Now we have traffic load. It's time to add fuel. So, what kind of fuel will you add? You will add takeoff fuel or fuel on board. So, zero fuel mass plus takeoff fuel will also give you takeoff mass. So, there are two different ways to get or obtain takeoff mass. There is another way. The third way is dry operating mass plus useful load is your takeoff mass. This useful load is made of two components. It is made of fuel on board and traffic load. So fuel on board and traffic load together is called useful load. So dry operating mass plus useful load also equals to takeoff mass. Then when you start your takeoff run, you take off in the atmosphere, you are in the cruise and you land at your destination aerodrome. So what will be your mass of aircraft? What will be the mass of aircraft when you land at your destination? So that mass is called landing mass and it is equal to takeoff mass minus trip fuel. What is trip fuel? The fuel that you are going to burn in your flight going from A to point B. Okay, so takeoff mass minus trip fuel, also called burn fuel, because you're going to burn that fuel. This gives you landing mass. Okay, and like I said, this takeoff fuel is exclusive of taxi fuel, startup and run-up fuel, right? So when you add taxi fuel, startup fuel, engine run-up fuel to takeoff mass, you will obtain ramp mass, okay, or you will get taxi mass. When you add up startup and taxi fuel, also taxi mass or ramp mass, that is the weight of aircraft at the beginning of taxi or at the ramp when it is parked on the ramp area. So this is the meaning of this whole diagram. You must remember this flow chart. It will be very useful in solving payload calculations. Now coming back to this question, variable loads. What are variable loads? Like I said, crew baggage, removable equipment, food, water, chemicals, etc. So this variable load is exclusive of payload or passenger load. Okay, it does not include passengers. So option alpha is wrong. Charlie is wrong, and crew, their baggage and unusable fuel. Over here it says crew baggage, that is right, unusable fuel. Now unusable fuel is a part of basic empty mass already. This basic empty mass is nothing but standard mass of your aircraft plus standard equipment or standard items like unusable fuel, unusable fluids, emergency equipment, etc. Okay, so you need not add another part or you need not add unusable fuel again in your variable loads. So delta can be eliminated. Now we are left with option Bravo. Removable equipments, crew and crew baggage. So statement Bravo or option Bravo is the right one. Next, the allowable center of gravity range is what? Is specified by the regulator like DGCA. specified by the operator, your company, specified by the manufacturer of your aircraft, calculated by the operator. So always remember, center of gravity, it's talking about center of gravity range. Now let's say here is your aircraft. Okay, we just now saw in the question number 1 that I covered in the beginning of this lecture, there will be a center of gravity datum, an imaginary plane from where all center of gravity positions will be calculated. Right? Let's say the center of gravity datum is outside your aircraft on this longitudinal axis. The center of gravity of your aircraft is here. Now, the center of gravity has the ability to move within two limits: the forward limit and the rearward or the uh, aft limit. Okay, so forward limit, the aft limit. Now, why is this so? Now, the center of gravity of your aircraft depends on the weight of your aircraft. Now, when you start your aircraft, when you start taxiing your aircraft, you take off, you fly in the atmosphere, you cruise, you descend, you land. So all this throughout this journey, the weight of your aircraft will progressively decrease. Why? Because as you start your engines, the point you shut down your engines, you will be consuming fluid non-stop. Fluid in the sense fuel, right? So at the beginning of your flight, the weight of your aircraft will be maximum because the fuel in your fuel tanks are unused. Okay, they are to the top up to the top level. But when you start your flight and as you continue your flight towards your destination, the fuel in your fuel tanks will start decreasing in quantity as you progress towards your destination. As the fuel quantity in your tanks dip or decrease, as you consume your fuel to go from point A to point B, the weight of your aircraft will also decrease by that much amount slowly and gradually, right? So this will influence the position of your center of gravity. If at the beginning of flight the center of gravity is here, it may happen as the flight progresses, the center of gravity position moves a little bit forward somewhere here. It moves somewhere to the back position somewhere over here. Okay, so this is allowed, this is bound to happen. Okay, it's normal. The only thing that we have to remember is that the manufacturer of this aircraft will specify, okay, a particular range. Okay, a particular range, that means the distance, forward distance and aft distance, within the range of which the center of gravity must move and remain. Okay, but it cannot move or exceed this limit. It cannot exceed this forward limit. It cannot exceed this aft limit, meaning it cannot cross this forward limit and go beyond it. Likewise, it cannot cross the rearward limit and go beyond it. Okay, it has to move within these two limits and stay anywhere inside those limits. So this center of gravity range is determined or specified by the manufacturer. Next very important thing. Now, when the operator of this aircraft buys this aircraft, purchases this aircraft from the manufacturer, the operator can further enforce or demand to have a more strict center of gravity range, a more restricted center of gravity range. So, if the manufacturer of this aircraft specifies a center of gravity range which looks like this, the operator uh, may restrict the center of gravity range further. So, the operator may say that instead of having this long center of gravity range, let's reduce this range to this limits. Let's narrow down this range to a new limit. Okay, so this decision can be made by the operator of your aircraft. So a restricted range, this is done for safety reasons or other factors. So restricted range, operator of your aircraft. The original range is determined by a manufacturer. Any changes to that can be made by a operator. Okay. Next very important thing, calculation. Now the center of gravity for every flight will be different because the weight of your aircraft for every flight will be different. Okay, so the weight of your aircraft will be influenced by outside atmospheric conditions, density, altitude, passenger load, fuel availability, etc. So it's very important that you calculate center of gravity every time you take off or every time before the start of your flight. So calculation of center of gravity is the responsibility of operator, whoever is operating that flight. So basically the pilot or pilot in command. Okay, now here the operator is a generic term. It means the pilot or the company. Basically the person or the company or the office that is operating this aircraft. So the correct answer here is the allowable center of gravity range is specified by the regulator, no. Specified by the operator, no. Pay attention to the word specified. Specified by the manufacturer, yes. Calculated by the operator. So the operator doesn't calculate the range. Range is fixed. Okay, it's not going to change. What the operator calculates is the exact center of gravity position. Okay, so the exact center of gravity position from the imaginary data. Okay, so pay attention to the words. It's they are talking about range. So range is determined by the manufacturer. 94. The center of gravity position. Now it talks about position. It doesn't talk about the range. So the position is specified by the regulator. Again, no. It's calculated by the operator. It's specified by the operator. It's specified by the manufacturer. So the correct answer here will be it is calculation of CG operator. So this is the right answer. Specified by the operator, a restricted, I'm writing here, a restricted or more strict center of gravity range is specified by the operator, and a normal or the original center of gravity range is determined or specified by the manufacturer. Next. Which of the following is correct? Moment equals to mass divided by arm. Arm equals to center of gravity divided by moment. Arm equals to moment divided by mass. Mass equals to arm divided by moment. So whenever you start, if you haven't flown yet, if you haven't begun your flying training, so you will definitely use this formula for the calculations of your center of gravity. It's very important for every cross-country flight. If you have already flown, you must be aware of this concept. So the formula is this: weight into arm equals to moment. Okay, weight into arm equals to moment. Now here the weight is the weight of that object. Arm is the distance from the datum. For example, this is the datum in this case. So at what distance from this datum is this object situated? Okay, so this arm is nothing but your center of gravity position in terms of distance. Moment. Weight into arm is moment. Moment is the turning force produced or generated by the weight of that object or the force applied by that object. So remember the formula: weight into arm, okay, weight of an object into arm distance from the datum. They can ask you this in your SPL Viva exam. So weight into arm distance equals to your moment turning force. So over here you have to cross multiply. So arm distance will be equal to weight, correction, moment divided by weight. Okay. So arm distance equals to moment divided by weight. Here mass means weight. So Charlie is the right answer. Next. The dry operating mass of aircraft is what? So like I said before, the dry operating mass of aircraft is basic empty mass plus variable loads. Okay. So this is one way to obtain dry operating mass. The second way is to obtain dry operating mass is operating mass minus takeoff fuel will give you dry operating mass. Okay, operating mass minus takeoff fuel will give you dry operating mass. Will give you dry operating mass. Third way is this: zero fuel mass minus traffic load or payload will also give you dry operating mass. Okay. The fourth way is this. Takeoff mass minus useful load is equal to takeoff mass minus useful load equals to your dry operating mass. So there are four ways. Now you have to pay attention to the options given. Okay, so we will come to know what is the right option. All up mass minus fuel load. Now in this case, all up mass means the takeoff mass of your aircraft. Okay, so all up mass minus fuel load. So our correct option should be all up mass minus useful load. Okay, useful load is a combination of takeoff fuel load and payload, right? Not just the fuel load, but also payload or traffic load. So we disregard option alpha, all up mass minus usable fuel load. So again, it's similar to option A. We know that it's all up mass minus fuel, that is usable fuel, and traffic load or payload. So Bravo is also wrong. Basic empty mass plus variable loads. Yes, basic empty mass plus variable loads like crew baggage, food, water is dry operating mass. Basic empty mass plus disposable loads. Okay, so that is wrong. So correct answer is option Charlie. Next. The basic mass of aircraft includes basic aircraft plus what? So basic empty mass is this. Okay, the very first weight of your aircraft. So it is made of two parts. First, very simple, your aircraft mass of your aircraft as standard equipment. Right? Now, the standard equipment means unusable fuel, unusable fluids, emergency equipment, all that, or any supplementary electronic equipment. So, the basic mass of aircraft includes aircraft plus removable catering equipment, unusable fuel and oils. So, this part of the statement is wrong. Removable catering equipment belongs to variable loads. It belongs to variable loads, not the basic empty mass. So alpha is wrong. Zero fuel mass minus passengers and their baggage. So zero fuel mass minus passengers and their baggage means traffic load or payload gives you dry operating mass, not the basic empty mass. So wrong. Zero fuel mass plus unusable fuels and oils. Okay, again irrelevant. So unusable fuels, oils, plus all standard removable equipment. So this is right. So option delta is right. So basic empty mass is your aircraft mass plus unusable fuels, oils, other standard equipment. 98. The operating mass of aircraft includes what? So the operating mass of your aircraft is your dry operating mass plus takeoff fuel or fuel on board. Now, this dry operating mass is in turn made of other two components, the basic empty mass and variable load. So let's pay attention. The operating mass of your aircraft is DOM plus takeoff fuel. Pay attention to the word takeoff fuel, the fuel in your aircraft when it is positioned ready for takeoff on the runway. So plus traffic load, no. Minus traffic load, no. Plus usable fuel, yes. This takeoff fuel, yes, is an usable fuel because you're going to use it for the purpose of your flight, right? So it's usable fuel plus usable fuel and traffic load. So that is again wrong. So DOM, so option Charlie is the right answer. Apart from that, dry operating mass plus usable fuel and traffic load or payload will be equal to takeoff mass, right? It will be equal to takeoff mass. Dry operating mass plus useful load, which is nothing but your fuel and payload, equals to takeoff mass. Next. Traffic load is what? Passengers, their baggage, cargo, non-revenue loads. Non-revenue loads means any cargo that doesn't generate any revenue for the company you're working with. Okay. Passengers, baggage, all revenue earning loads. All revenue earning loads only. All revenue earning loads plus usable fuel load. So correct answer is option alpha. Passengers, their baggage, cargo, and any other cargo which is non-revenue generating. That means non-revenue load. Operating mass is what? Again, the same question. Dry operating mass plus unusable fuel, wrong. Usable fuel plus dry operating mass, yes. Usable fuel means takeoff fuel. Dry operating mass plus traffic load is your zero fuel mass, not the operating mass. DOM minus unusable fuel, there is no such thing, so delta eliminated. So option Bravo. Okay. DOM plus takeoff fuel equals to operating mass. So this concludes our lecture. I hope you have understood all the 10 questions I have answered in this lecture. If you have any questions, let me know in the comment box. Thank you for your time. I'll see you in my next video lecture where I will solve the next 10 questions. So don't miss that.